All right, you are supposed to assume that the correlation coefficient is positive 1. What that means, first of all, is these two assets are going to move in the same direction. If V goes up, W is going to go up. If V goes down, W is going to go down. They always move in the same direction. That's what a positive correlation means. If it's 1, if it's positive 1, that's a perfect correlation, which means they will always move exactly in the same direction, and they will move in equal amounts in the same direction. So, assuming that that's 1, describe the range of expected return and the risk associated with all possible portfolio combinations. So it's two different questions that it's asking. So here at the beginning, we are looking at just this part. Expected return from these assets. If we were to make a number line, and on this number line include our lowest expected return, 8%, and our highest expected return of 13%. 8% is representing the return of V, and 13% represents the return of W. Over here on the left, we're saying that we have a positive perfect 1 correlation. According to your text, that simply means that your range of values for this is going to always fall between these two numbers. It can never get higher and it can never get lower. Once again, right now we're talking about the return. In fact, the text goes on to say that it doesn't matter if the correlation is perfectly positive, perfectly negative, or if it's 0. This is the answer for the first part of questions A, B, and C. The expected return range is going to be between 8% and 13%, and it includes those numbers. Hopefully that makes sense. Or at least, if it doesn't make sense, understand that this answer is always between the two numbers that you're given. It's always from the low to the high, no exceptions. Second part to this question, assuming that it's the same positive 1 correlation coefficient, describe the range of the risk associated with all possible portfolio combinations. So here we're looking at the assets and the risk. So we're ignoring the middle column. Once again, you have a number line. On this number line, it represents these percentages, and you got to make sure you have your lowest percent on there, which in this case is 5%, and you have your highest percent, which in this case is 10%. Of course, there's other numbers that go off here to the right and to the left, but we are focusing on those two right now. And once again, our correlation coefficient is a perfect positive 1. For this particular case, where that correlation is 1, your range of values is simply from the low end to the high end, just like in part 1. This is not the case for all correlations, but for a perfect correlation coefficient of positive 1, your range of values for your risk goes from 5% to 10%. And the 5%, we're looking at the standard deviation for V, and the 10%, we're looking for the standard deviation of W. Second question, second part to this question. It's the same table, same information, same words. Assuming the correlation coefficient is 0, describe the approximate range. That's important to understand. As I was reading through the text, I was having a hard time understanding exactly how they were getting their numbers. And the answer is they don't really know how to get the right numbers, is my guess. This is an approximation. It's important. Describe the approximate range of the expected return and the risk. So it's the same question as the first one, but now we're saying the correlation coefficient is 0. As previously mentioned, for the return, the answer is the same for all three of these. Your return ranges from 8%, and that is for V, all the way up to 13%, and that is for W. So at 0%, at a 0 correlation coefficient, you would expect this return to be between those percentages. This is the same answer each time for the return. You would expect the return range to be between 8% and 13%. Second part of this question, describe the approximate range of the risk. Now I highlighted approximate before, but approximate doesn't relate to the first part of this question. It's the second part. First part is the same for all three of these. The risk, however, this is where the approximation comes in. So we're looking at, once again, this column and this column. If you look closely, it's a little guy with glasses. Perhaps some kind of a schnoz here. Maybe a little smile. I don't know. See what I did there? Anyhow, let's get serious. This is no time for joking. So please don't be that way. Serious time. Anyhow, we're looking at these two bits of data, or as they say in Canada, dater. You once again have your x-axis, and our risk goes from 5%, and that is for V, and then we have our upper end, which is 13, pardon me, it's 10%. And let me erase that. This is a new app, so bear with me. That's supposed to be a 10. So we got 5% to 10%. Now, once again, we are looking at this from the perspective of a 0 correlation coefficient. So we got 5 and 10% here. Now the range of values, this is an approximation only. We would expect this range of values to fall someplace less than 5% all the way up to 10%. So if the correlation coefficient is 0, you expect the range to be someplace between the lower end and 0. So if you have to actually give a number answer for this, I would say it's approximately, the range is approximately 2.5% to 10%. That's an approximation. 2.5 is halfway between 5 and 0. So that's why I picked that. Once again, it says an approximate range. This is an approximate range. 2.5 to 10%. The 10% I'm solid on. That's definitely the upper end. 2.5%, that's where the approximation comes in. This here was R of W on the right there. So this was the risk, and we did the return. The return's the same for every one of these. Third part to this question, it's the same basic question again, but this time it says that the correlation coefficient is -1. So we're supposed to find the return, That's using the first two columns once again. We have a horizontal line each time. On this horizontal line you have your low end, 8%, you have your high end, 13%. 8% was representing the R value of V, 13% was the R value of W. Over here on the left, we're looking at the -1 as the correlation coefficient. Once again, we draw vertical segments above the low and high end, and once again, for every one of these, dealing with the return is going to fall between the upper and lower. For the 9th time, just want to make sure this is clear, this answer is the same for every one. The range of values is 8% to 13%, and once again this was returned. The return, portfolio return percentage. Last part to this question, we're looking at the assets again, and we're looking at the risk. So find the possible range of values for the risk. You once again make your horizontal. On this you have your lower end, which was 5%, and your upper end, which is 10%. 5% was for V, 10% was for W. Over on the left, we have, on this vertical axis, we have the correlation coefficient of -1. Perfectly negative. I don't think I discussed what perfectly negative means. Probably should do that. It means as V gets bigger, W always gets smaller, every time. If V gets smaller, W will get bigger. So an example in real life of something like that is true. Let's see, what can I think of? I can't think of anything. If I think of something, I'll throw it out there. There's many examples. Just can't think of any right now. So once again, above these values that we have here on this number line, we draw vertical segments above them, showing where the 5 and 10% are. The high end of the risk is always, for every one of these problems, always goes up here to the end, 10%. But because of this negative correlation, if the risk for W keeps going up, that means the risk for V is going down. So this can extend all the way down to 0. So for the risk, for this problem, we're saying the risk can go from 0% all the way to 10%. And that is for the negative correlation. These answers are standard answers each time. So in a nutshell, what I'm saying by that